And we're live. Welcome everybody to the first webinar of our 2021 Smart Building series. And we're starting off big. We're starting with a catch up with the brick schema. I'm really excited to do this. These guys really insightful. And we're going to be providing you with a full update today on some of the concepts and features in the new pending version 1.2 of the brick schema. I'm just going to kick things off here, and then I'm going to hand over to the guys who are going to do a full presentation with some slides for you on what's coming up. So just from me, guys, imagine as we go through, people are going to have questions. We are happy to do that, although in this situation, there's quite a lot of content to go through, so the majority of the session will be slides. But if you do have some burning questions, we've tried to leave some time at the end, and we'll be able to take some of those. Other than that, we are recording the session as well. So that will be going up on our YouTube channel. And please, feel free to listen again or share that with colleagues if you think they're going to be interesting. So without further ado, let me hand over to the guys. Please go ahead.
All right. Hi, everyone. We'll just introduce ourselves quickly before getting started. My name's Gabe Fierro. I'm a final year PhD student in computer science at UC Berkeley, and I'm one of the lead maintainers of the Brick Ontology project.
Hi, everyone. I'm Jason Ko. I'm formerly a PhD student at UC San Diego, now a chief data scientist at MEPS. I'm also one of the lead maintainers of brick schema.
Hi, my name's Erik Paulson. I'm calling myself a data engineer these days at Johnson Controls in our AI hub. My PhD is from the University of Wisconsin, and I'm glad to be here today.
All right, so we're going to be talking about what's been going on with the brick schema over the past year or so since we last held a webinar. And so the sort of operating principle that I want to start with, which I think a lot of us are on the same page with, is working with data in buildings is hard. It's really hard. And one of the reasons it's hard is because there's no consistent machine readable representation of the data sources, what's producing that data, and the context, where that data is, what's it connected to, what's it doing, what does it mean, and so on. And essentially, we need semantic metadata. We need data about that data that's going to communicate what this data means that's coming out of our buildings. And we'll go over sort of how to do that. But today, if you open up your BMS and you take a look at the point names in your BACnet network or your OPC network or whatnot, you're going to find essentially for 3 different buildings, you're going to find 3 or more different labeling or naming schemes. And those names have to do a lot of work because they're basically, the only thing that's capturing all of that context of what is this particular data stream. But the problem is looking at that point name, you have to, encode the location of the point, the function, the equipment it's connected to, what the subsystems are doing, and all of that more in a single label. And so what you end up with are not only site or vendor specific conventions, but conventions that assume expert domain knowledge and familiarity with the building. So just in this one point label from the computer science building on the Berkeley campus, we've got 16 characters or so, and there's we have to divide them up in these seemingly random chunks in order to correctly interpret, oh, this is a room temperature set point that's in a particular room that's served by a particular air handling unit that's in a particular building, and so on. And so this is not something that we can really do at scale. This is something that's going to take a lot of effort to parse through manually. And to sort of describe the state of affairs, what you have is most of your building data residing in these opaque data silos where you have unclear, inconsistent labels, if you have access to it at all. And while there have been efforts and movements to try and standardize the metadata and the other digital representations of the building, most of those are focused on other perspectives of the building, such as design, asset management, commissioning, and auditing. And as a result, they don't quite capture exactly the metadata that you'd need in order to construct the analytics and controls and other data-driven applications you'd like to execute. And so what we need is a metadata representation designed for data-driven building software. We want to be able to unlock that potential of all that building data while, and we'll get into this later, preserving the existing investments in the digital representations that may already exist for your buildings. So here's a quick outline of what we're going to be going over in this webinar. I'll sort of review the main design concepts of the brick ontology and give you a quick refresher. Then we'll talk about what's new since last time, talk about the new tools and documentation. Then we'll talk briefly about how to start building software with brick, how to start writing some of those analytics. We'll touch on how to make brick models. We've been doing a lot of work here to make this easier to do. And then lastly, we'll touch on advancements in the brick community, including the new nonprofit consortium and how you can get involved. So what is brick? Brick is, at its core, a graph-based metadata schema for smart buildings. What that graph is going to do is it's going to capture representations of the physical, logical, and virtual entities, the stuff in the building, using a class hierarchy. And it's also by virtue of that graph structure, it's also by virtue of that graph structure going to capture the necessary relationships between that stuff that's inside the building. And what this is going to do is that graph is going to describe the time series data that's in the building and its context. And we'll sort of precisely describe what we mean by that. But I want to say that Brick is not just the three of us alone. Brick is a collaborative effort from a collection of these universities and companies that have been involved from the beginning. At its core, this Brick is driven by the needs of its community, and that's something that we'll touch on later as well. So what's inside Brick? We'll start with the class hierarchy. There are three main concepts in Brick: the point, which represents telemetry, sources of data in the building; location, which represents not just physical locations like rooms and floors, but also logical locations like zones; and lastly, equipment, which are the devices and the things that are actually performing actions in the building. And what these classes do is they provide definition and organization to the entities. So when I look at a thing that's in my building, I can look at its class and I can understand what it is, what it's supposed to do, and other properties of that item. And what the relationships do is the relationships dictate how these entities correspond and relate to one another. So in this diagram here on the right, we can see that things that are points are related to equipment through the is point of relationship. This means that that data source is associated with that piece of equipment. Points can also be associated with locations. So if you have an air temperature sensor that's in a room, you know where that data is coming from. Equipment can be associated into sequences. So you can know how air or water passes through a system using the feeds relationship. Equipment also passes that physical substances to rooms or zones through the feeds relationship. And then lastly, we have composition, which is how is equipment made up from made up of itself? How is location made up of other locations? And so through those three sort of main, four main relationships, we're able to actually capture a lot of the nuance and a lot of the structure of how these buildings work. And so to present a simple example, we start building our graph up from the entities, the physical, virtual, and logical things, and points that the application wants to be able to refer to. That's in blue here. For each of those, we can now attach a class pulling from the Brick class structure. So we have a definition for the variable air volume box. There's a definition for supply airflow set point, and so on. And then lastly, using the feeds, has point, has part, and has location relationships, we can build up the semantic graph of how is this building or how are these particular systems put together. So we've got our air handling unit at the top. That air handler unit is passing air to two VAVs. One of those VAVs feeds air to a zone, which consists of a set of rooms. The other VAV has a damper, which has its own point, and also has a collection of points. The sensors, the airflow sensors, and supply air temperature set point, and so on. And so what that graph is going to do, that brick model was going to represent the assets and relationships and data inside the building. And from that digital representation, that abstraction of the building, our application can then query that. So rather than the application having to deal with all the particulars of how a particular building is represented, what the particular point label representation is, it can now query a standard semantic machine readable representation of that building in order to retrieve the data configuration it needs. And Jason will be speaking specifically about how we can accomplish that later in the talk. And the mechanism that we're going to be using there is between the points that are inside our brick graph, the metadata about the building, we're going to be able to contextualize the actual time series data itself, which may or may not be stored in a different database, but by characterizing the links between the data source, the data itself, the data sources, and where those data sources are, that's going to provide us with the sufficient context and metadata we need in order for these applications to run. So before I get into what's new in Brick, I just want to give you a quick sort of 30-second overview of what Brick might look like for a more complex and more realistic building than the one that I just showed. So here we've got our air handler unit in blue. It's got its, all the fans, the heating coils, a bunch of sensors and set points and motors and valves and dampers all over the place. We've got two VAV boxes feeding two different zones. Those zones consist of rooms. Those rooms consist of lighting zones and lighting fixtures. And then we've got the exhaust fan and air returning back to the air handler unit. And so what this looks like as a brick model is this big graph right here. And so, I'm not expecting you to
Hi, Gabe, have we lost your audio?
Oh, I'm sorry. I have a little bit of an iffy microphone there.
No worries.
Yeah, so I'll start off for the location model. So if we zoom into the location part of this brick graph, we can see that our site is made up of buildings. The building is made up of floors. The floor is made up of zones, which are either HVAC or lighting. And then we've got the rooms that are part of those zones as well. So we've got that decomposition there. The VAV models, we can see, my VAV box consists of different parts, such as the heating coil and the damper. It feeds an HVAC zone. We've got pieces of telemetry that are associated with each of those components. And then for something complex like an air handler unit, you can see the much richer interconnections of how the different points and different pieces of equipment relate to one another. And all of this is captured in a consistent machine readable way that we'll be able to write code against later. Okay, so now I'll talk about what's new in Brick. First off, improved developer documentation site, docs.brickschema.org. This is still a work in progress, but already what's there is a ton of really useful information about how Brick is implemented, how Brick is intended to be used for different types of applications, what are best map modeling practices, how do validation and inference and reasoning work, when would you want to use these features versus the others. And so we hope that this is a resource that the community can contribute to, but also helps inform a lot of the sort of design decisions that go into how would you incorporate Brick into your own analytics stack or your own piece of software. We've also launched a public development roadmap. One of the core tenets of Brick is transparency and openness. And so what the roadmap does is it makes clear to the community where we are planning on going, what the features are that we're planning on introducing in versions 1.2, 1.3, and longer term features as well. And so that's something you can visit. This is all managed on GitHub. So if you have your own contributions or features that you'd like to introduce into Brick, you can just open an issue with a free account, and that's something that can be merged into the public roadmap. We also have an expanded set of brick classes. Brick is constantly growing as we come across new building systems, new types of equipment, new regions of the world that want to adopt brick that have different kinds of systems involved. And to just touch on a few of these, we have over 100 classes added since version 1.1, and that might even go up by another 20 or 30 by the end of today. So we've got expanded location and room types. So we've borrowed location designations from existing ASHRAE standards, existing documents from large property management firms to better sort of categorize what rooms are used for, what spaces are used for. We've also been working with some researchers from around the world on expanding the set of electrical metering points. So it's not just power sensors and active power sensors and reactive power sensors, but also capturing things like phase and so on. We're also working on expanding the set of weather stations and weather station related points to better describe the data and telemetry that are coming out of those. Thermal energy meters, you can see on that issue in the figure. We're working on expanding the set of chiller related points and chiller classifications. So this is something where we designed brick from the beginning to be extensible. We designed brick to be able to be extended with new classes and new concepts and new areas. And that's something that we're continuing to do. Just the other day, I was having a conversation with researchers from Finland that are working on adding district heating related points to brick. And so that's a feature that we should see soon as well. Related to the set of classes, we've also been working on better ways of describing the classes and the entities that are classified. And the way to do that is both with units of measure and with the entity properties on the next slide. So what the units of measure do is for each point, so for each point class in brick, and recall that a point class represents a source of telemetry or a sink of data in the building, such as a sensor or a set point or command or alarm and so on. Those class definitions now have a set of possible or permitted units. And this is built on the open QUDT standard, which stands for quantifiable units and data types. And what essentially that does is it models that because we know that a temperature sensor measures temperature, specifically thermodynamic temperature, that restricts the set of engineering units that should be applied to that. And so inside the brick ontology definition itself, when you look at temperature sensors, you see, oh, this should be either Fahrenheit, Celsius, Kelvin, and so on. And when you actually instantiate one of those, I create a temperature sensor in my brick model, I can now say this has a particular set of units associated with that. And because the ontology is capturing the set of possible units, we can now do things like verify that the units for my sensor are appropriate or make sense. And I can also use this to drive automated creation of those units or automated checking of that, where when I'm going and creating a brick model, I can now ask what units could I associate it with this? What are the supported units in brick? The other feature, which we're very happy about, is the entity properties feature. And essentially what this is structured and standardized key value pairs for entities. Not all metadata can be represented as a class, and so brick will soon have the ability to capture things like room volume, floor area, electrical characteristics like phase count, nominal voltage, and rated power, other equipment nameplate characteristics such as max rated speed, and lastly, things like aggregations, like how is this particular point aggregated? Is it a daily max? Is it a monthly average? Is it an hourly sum? And so on. And so we've been working on an initial set of these for version 1.2, and we're definitely, accepting community feedback and extensions for the kinds of properties that people would like to add to brick moving forward. And to look at this figure on the right here, we can see that when you get that class definition, you're not just getting a human readable definition from some authoritative source. You're not just getting the possible units, you're also getting properties about how that particular class behaves. You're getting tags that let you find that class later. And when you create that instance, you're inheriting all of those properties and tags. So all of your instances and your entities in your brick graph have this very rich description that they inherit from their class description, but you can also now add properties to the instance itself. What is the identifier in the time series database? What's the IP address of a particular device, and so on. More of what's new for Brick, new and improved tools. I'll talk about the brickschema Python package in just a slide, but we also have improved translation and conversion software, which Erik will talk about later, as well as alignments with and conversions from existing metadata representations to increase Brick's compatibility with the other efforts in this space. Related to the tools, we also now have a mechanism for doing the validation of Brick models, which I'll also touch on in a couple of slides. So what Brick model validation does is essentially allows the definition of templates to validate Brick models against the expectations or requirements. This might be based on a particular model. This might be based on the requirements of a particular site or deployment. But essentially, you can verify now that Brick is being used correctly, and not just correctly, but to the specifications that have been laid out by a customer or a piece of software or so on. And so in this example here, we've got a model XYZ VAV, and the requirements of that template are it's an instance of the Brick VAV course class. It has a zone air temperature sensor. It's got a temperature set point, and it contains a damper, and that damper is its own template.
Gabe, we lost your audio again.
You did? Oh, I'm sorry. Okay. So you heard both the VAV and the damper class description?
I'm not sure, like.
I think if you go back to just the damper class, I think.
Okay. All right. Yeah. Thank you. So our VAV template requires that we have a model ABC damper. That model ABC damper is its own template, which has its own requirements for what class it should be and what points are associated with it. And so our sample graph at the bottom, because it doesn't have the associated points with the damper, this does not validate. And of course, we'll get a detailed report out that says exactly what is missing. And if we did have if you did have a graph that was complete, then of course, the validation does tell you that you passed. I also want to touch on the Python library that we've been putting together. We've been using this to develop the Brick schema and develop some software, and it's been pretty useful for us. So you can, in the version 0.2, so if you have already installed this, you'll need to upgrade. But after you do your pip install Brick schema, you can automatically load in the latest Brick definitions. So this will, either load it from the package or pull it down from the website. So you have the latest up-to-date version of all the Brick definitions. You can load in different graph files or turtle files from your local file system. You can load them from the web. You can also convert from existing sources. You can also now apply logical reasoning and inference to that. You can validate the model with the simple function call. And all of that is, just a 1 or 2 lines of code away. And then lastly, you can now run Sparkle queries in your program. So after you've loaded in your graph, you've validated it, you've used a reasoner to produce all of the extra logical implications of the statements that are inside your graph. You can now run queries against that. This particular query is getting airflow set points and sensors for a bunch of VAVs. So you can do things like rogue zone detection. And you can now call .serve on your graph. And what you get is a web interface that presents your entire graph in your browser. You can now program against that. You can run queries. You can observe the results. And there's some helpful buttons along the top that let you add additional information to your graph if you wish. All right. And so that's been the overview of what's new with Brick at a 30,000-foot view. And I'll turn it over to Jason for talking about writing building software with Brick.
Thanks, Gabe. So I'm going to talk about how to write building applications with Brick and with few more detailed examples, like on hands-on tutorial. So, like most web applications, building applications have a similar workflow as discovering the resources of interest and then get associated data or apply some actions like actuating controllers. Next. Those data may come from various data sources, such as vendor-agnostic protocols like BACnet and Modbus, or vendor-specific interfaces like Metasys API. Next, and connectors read data from such data sources, and those connectors are usually need to be highly customizable across different implementations. That you can check our example connector brickschna. And those the connectors relay the data from the data sources to databases that our applications can access, including brick databases for metadata and Timeseries database for telemetry, and possibly with some supervisory control interface. There are many implementations for both metadata and Timeseries databases, but to just name a few, LDF Stores, HotDB by Gabe, LDF Lib, or AWS Neptune, and so on. Or you can even use Brick with other types of the databases too, like your favorite document database or SQL databases, and so on. And there are just too many options for Timeseries databases, like TimescaleDB or Influx database. And because metadata and telemetry data are stored in different places, your next question would be probably how to actually utilize them together. Next. And because those are stored in different databases, we need shared references so that we can uniformly refer to across different databases. And here we call has Timeseries ID, though we currently do not dictate how exactly they should be modeled because those are very specific to implementations. But we are currently working on a guidance for the best practices. So once you identify, sorry, can you go back? So once you identify the entities you're interested in with Brick, you can check its Timeseries ID and send a request to the Timeseries database to get all the telemetry data with the ID in a time range of your interest. So let's see how to actually use those in the discovery process in two more specific examples. So these days, it is our top interest to understand whether the air of a place is fresh or not. Next. And to do that, one may ask how many people have been in the conference room, because the humans are the major source of the contamination. And of course, we need to understand the air circulation rate, more specifically, how much air of the entire room has been replaced, or air change rate per hour. So several research articles recommend to keep more than 3 ACH for office spaces. But note that this is not currently, I'm not giving a medical recommendation or control guidance, but I just want to show, given such a policy, how easy it is to implement it with Brick. And we are going to focus on the air circulation rate in this application. So this is the Brick model of a room's VAB. So from top to bottom, you can see that the room has a volume property and its associated HVAC zone, which is controlled by a VAB, and the VAB has a supply of flow sensor. Next. Given this model, well, we are interested in the Timeseries data of the supply of flow sensor and the volume of the room to understand the air change rate of the room. So let's identify the rooms of VABs first. Starting from the target room 101, we are traversing up to the VAB. And note that you don't have to specify the specific type of the terminal unit because Brick's type hierarchy can abstract the complex types. And VAB is a subclass of terminal unit. So this way, your query will work with any kind of terminal units other than VABs too. Next. Then you can find the supply of flows time series ID, which we can use to get actual time series data from the associated time series database. Next. We can also find the room's volume by Brick's newly introduced feature of scale-up properties. We are explicitly modeling units as well, so any application can unanimously interpret the values. So now we can retrieve the airflow rate from the time series database, and the volume of the room is known, so we can calculate the air change. So let's check another application. So here, this is a hello.
Hi, Jason.
Yeah,
Jason, yeah, we just your audio is going in and out a little bit.
Yeah, I don't know what's happening with my audio, but let's try a few more.
Sure, let's go. Let's go.
Yeah. So this is a part of G36 guideline for can you hear me okay? Sorry. Oh, so this is a part of
sorry,
yeah.
yes, we can hear you now.
If this happens again, I will switch audio. So this is a part of sorry, give me a moment.
Just while we're waiting for Jason to sort out his audio a little bit there, we've been trying to answer actually questions in the Q&A with text, so that's great. I know I can see Gabe's typing something in now as well. So that's great. If you do have specific questions, then please type them in. If we don't get to all of them, like in the text, then like we can try and cover them in the audio at the end of the presentation. Beyond that, I'd say like some of the questions I've seen, and if you look at the brickschema website, there's a really good sort of description of what it's about, and make comparisons with other data projects out there as well. They do that on the website, and there's lots of resources there. So after the session, I would definitely encourage people to go and take a look at the website.
Hi everyone, can you hear me?
Yes, we can hear you.
I'm sorry, I'm really sorry about that.
That's all right.
Issue. Okay. So going back to the G36 guideline, so this is showing the rules for AHU fault detection, and there are various rules that we can uniformly retrieve from the necessary entity, retrieve the necessary entities from a brick model for that. So we'll go over those the questions on the right side shortly. Next. This is the, sorry, can you go back one slide? So this is the air handling unit diagram Gabe presented earlier, and it contains quite a bit of information about their devices and points. And what we actually need is quite simple. Can you next? So this represents among the complex model, we are mainly interested in those entities. One can tag them as return air temperature sensor or supply air temperature, but their relationship is also important to relate them each other. Next. Which is they are all functioning for the same air handling unit, one, and such relations are represented by has point for points and has part for the equipment. Now we are ready to answer the questions on the right side. I won't go over the details of actual queries as in the previous example, but you should be able to get the idea. It's similar to the previous one. So to check the calibration of sensors, one can check if the mixed air temperatures values are between outside air temperature and return air temperature. Next. And to check whether the equipment is stable, we can check the air handling unit unit start to stop command frequency of changes over time. And if you want to check the status of the economizer damper, which is hidden in the diagram, we can check the difference between outside air temperature and mixed air temperature. We can check the difference of those two is large enough to see the damper is functioning properly or not. As you can see, Brick can simplify the discovery process with types and relationships. This is my I'm reusing the slide that Gabe presented earlier. This is my favorite diagram across many Brick presentations. Resource discovery is made easy because Brick can easily abstract the complex hierarchy, while the relationships can be used to unanimously identify what entities actually the application is interested in. So now you're probably interested in, how to actually get those models out of your building, and I will let Erik to talk about it.
Great, thanks, Jason. So this probably shows me as Gabe just and more audio craziness. I had the wrong link. Gabe forwarded me the link, so I wound up using his Zoom link. So it both shows. So both of us are showing up as Gabe. This is Erik Paulson for Johnson Controls, and I'm going to talk about creating some brick models. And so brick models are RDF data and go into an RDF database. And so just like creating a database for a relational database, you can always start at the most basic level, and you can just, like with a relational database, you can type it into a CSV. With RDF, you can always type it into a serialization format like Turtle and import it right into your database. That's a little painful, so you're going to look for some better options. First off, Brick doesn't take a position on which database you use, and so the database you're using very well almost certainly has some kind of data loading capabilities and maybe a data studio of some kind, or if not, there are commercial data studios for RDF that you can use to import that data. So I won't get into that, but that's always an option, and you can explore that with your database vendor. One way that we found is very useful is using a programming language to write ETL code to push into the database. Here I'm showing Python, but there's nothing special about Python. You could use use the programming language of your choice. It's RDF and it's well supported in basically every programming language available. So here, this is a very simple programming language, a very simple program that's only going to put a couple of objects into an RDF graph and write it out to a file. But you can imagine here that you have the full power of your programming language to access your data and pull it in. So if you want to read data from a SQL database, or call a REST API, or parse an XML dump, or whatever works for your data set, you can read that data, manipulate it in the programming language, and write it back out. And this gives you a lot of flexibility and is in many ways, and will be a path that many folks take to build up a brick model. Now, if you don't need to program, we can move on to the next example. If you don't want to do everything through programming languages, we've got a couple of other options, and this is certainly by no means exhaustive, but one of the common scenarios that we see is that people have some kind of set of messy data. They already have a data set that might be a little bit messy, but there might be some structure to it. Think back to that very first opening slide where Gabe showed 3 sites with 3 different naming conventions. Yes, it was messy, but there was some kind of structure in that. There is a little bit of pattern, and maybe we can do something with that. And so we've actually had a lot of luck using this tool called OpenRefine. It was originally from Google. It was their data wrangling tool that they used to help build their first version of their knowledge graph. And it's designed to process that data. So we have a full 20-minute video of using this. So I'm not going to get into the weeds too much, but OpenRefine, think of it as a super powerful Excel that's designed to sort and slice data into chunks and then perform an operation on that chunk. It's visual and user-friendly, well, reasonably user-friendly, and it's designed to make easy work of data where the data usually matches, but sometimes there are exceptions. So it helps sort out the exceptions from the common cases and makes it fast to sort the data out, apply an operation to clean it up, and then do something with it. Another great feature of OpenRefine is this reconciliation API. So in knowledge graphs, you often have to match against another data source to sort of figure out what it means. Imagine you had a column of cities and there was an entry in there for Madison, and you're trying to figure out, is that Madison, Wisconsin or Madison, Alabama? And the reconciliation API is designed to help that, help you figure out which one you're really talking about. And so we've been using this to classify breakpoints. So is this a heating set point or just a heating sensor? You know, what is this, and how can I how can I help sort this out? And the reconciliation, it's a web service that OpenRefine integrates to, and OpenRefine can send off these candidates. It can send off this sensor name, and the web service responds with, here's a couple of candidate classes, and then the user can pick the right one. If they all match, they can bulk match them right away. So it's got a nice user interface to sort of do this sorting out. So we have a very basic version up and running, running on brickschema.org, and we're working on expanding that to build a smarter version. So can we use natural language processing and other AI techniques to give back better answers? So let's move on to the last thing I would say is that kind of after you do that data wrangling and conversion, you'll want to export that data into a CSV file or something. And so then once you have a CSV file, how do we turn that into a brick model? If I don't want to have to write a Python program to read that in and do this, one of the things we've been exploring is can we give you a template that says, here's how I'm going to reshape that data into a brick model. And so on the left here is an example template, and it's designed to be applied against a CSV file. So you write a template that matches the columns of your CSV file, and then the software applies that template to every row of your CSV file. It's got some basic, you can get pretty far with this template. So over on the left is an example template. Over on the right is just the start of the output that we were able to generate from the data that we had from the OpenRefine session. The template language includes some very simple logic to include if a statement should be, if a statement in the template should be used to output a new entity into the model, but you can get pretty far with this without having to know much programming. Just be able to write some basic template and you say, which column do I want to show up where in my graph? So can we go to the next slide? So OpenRefine is open source. We didn't write it. It's out there available today. Brick Builder is a tool that we wrote. It's on the web. There'll be a link to it later. But OpenRefine is a little bit limited. I'm sorry, Brick Builder is a little bit limited in that the logic is, it's not quite enough to do a lot of what you might want. So we started by exploring, can we use more expressive templating languages? So there's systems like Jinja or Handlebars that web programmers are really familiar with and have used very successfully to build sort of data-driven web pages. And could we apply that to brick models as well? And can we use that to create more sophisticated brick models? And what we've kind of worked on is a new tool that we're calling Brickify. We may change that name. But what we wound up with is an abstracted software architecture tool that is more flexible and supports multiple transformations to the data. So we have a library of transformers that we can handle importing data from. So you don't have to worry about, we want to provide as many transformers as we can. So some of the things that we've got now is we've got Jinja templates, we've got BMS formats, We've got haystack JSON, and we're working on developing more. So you can take those templates and you can customize them if they don't quite match what you need, but they can be customized. If your site has a naming convention, you can build a template that works for your site, or whatever. We want to build, we want to make it easy to not have to know a lot of programming to use this. So let's jump ahead to the next slide. Another tool we're working on is using BIM data to create a brick model. BIM through IFC or similar systems like Revit. They have a great data model for design, for explaining construction, but they don't always have quite the richness that you'd want maybe for your brick model. And so what we've been looking at doing is, can we take the IFC data model, and I'm just going to use IFC and BIM kind of interchangeably here, which might make some folks mad, but I'm going to run with it. Can we augment that IFC file by adding a couple of properties that we can have a tool look for later downstream, that they can combine that augmented data with the data structure that's already incorporated into IFC, and can we use that to output a BIM model? So can we make it richer than we'd be able to normally get from an IFC file, but can we leave that data in a BIM file so your BIM editor, your BIM team can edit that, put it into the BIM file, and as they continue to edit that building, that data stays with the BIM until they finish it up and output the BIM file. Our tool right now uses Autodesk Forge, the Forge web services, and so as a happy bonus, we'll use Forge to parse that Revit file. It actually spits us back. It includes the IDs of the 3D objects, so you can build a 3D visualization. So you have all the IDs of the 3D objects in your brick model, so you can use that to build a 3D visualization using the Forge Viewer JavaScript library, and you can link the 3D object to your brick model in your visualization tool. And so we hope to open source that soon as well. And then I'm going to turn it over to Gabe to talk about some of the work that he's been doing.
Yeah, so we're running low on time, so I'll sort of go through this at a high level. We recognize that there's different representations of the building that have different roles in the building's life cycle, and each of these are different because they're designed for different kinds of applications. The representation or the abstraction of the building you need for design and construction is different than what you need for operations, is different than what you need for auditing. And so one of our goals in these new versions of Brick is to preserve those existing investments. So how do, like the way that we build on top of IFC and enable the Brick model through the IFC and the BIM, how do we work with these other representations as well? And so what we've been working on are ways of supporting conversions from, and hopefully to some of these, to these different representations. So if you're working with VBIS for asset management, or Modelica for modeling your sequence operations, or you're working with Haystack for managing your data, or Building Sync for running your audits, you can produce a brick representation from each of these models and use that to drive the creation of your applications. And so we wrote a paper on this, which we presented late last year. And so there'll be a link to that paper at the end of the talk. But essentially the way this works is we have pieces of software that produce brick models from each of these individual representations. And they merge and reconcile these into a single cohesive brick model that does things like, and what this process does is it will merge the different identifiers. Not all the labels are the same everywhere. It'll identify gaps or holes or mistakes or things that aren't up to date in these different models, and does a lot of that work to sort of produce the brick model that your application developers can use, and to a certain extent be agnostic to where that data came from. And so the goal here is that you can have all those other representations that enable other parts of your building operation and lifecycle while maintaining that brick model that can be used for applications. So now I'll turn it over to Erik to talk a little bit about the Brick Consortium.
So Brick tries to address an industry need. So we want to make data more interoperable between different systems. And BACnet has been around for over 20 years now, and it's been very successful. We want to provide a path for Brick to make sure that it's available and sustainable for 20 years and to continue its mission. So we don't want to replace all the other data standards in the world. We're never going to replace IFC. We're not going to replace COBE. We're not going to replace GBXML, but we want to make it possible to be a bridge between all these different data sources, including data sources and domains that Brick doesn't deal with today, and including things that don't exist today yet at all, right? So like what technology will be new over the next 20 years, and how will Brick evolve to support that? So that's what the Brick Consortium is here. It's a nonprofit of researchers in industries and funded by the industry partners to provide a path for this. It's going to provide governance development of the Brick standard in a open, vendor neutral forum. So developing the schema, developing tooling, working on conformance testing, and providing a set of canonical use cases and reference solutions. It's going to fund research and development work related to Brick in the built environment, and then we want to evangelize Brick and help grow the entire industry. And so just jumping on to the next slide, how the consortium works, it's organized around working groups, kind of building bottom up. The working groups are the schema development group. Most of what we've been talking about here today, what the classes are, what the relationships are, how that all works. Then there's a group around tooling, how we're going to build tools to create Brick models, to manage Brick models, and so on. And then two groups that we haven't really talked too much about, a group around public research data set creation. Can we collect anonymized data to help make it easier to develop new applications and analytics, and then an actual applications and analytics development team. So can we build open source tools and applications to complement what's happening in the commercial world? It's overseen by a couple of committees, a steering committee, and then technical committees. The members vote on when the new schema comes out, but you don't have to be a formal member to participate in the open source work. We want to be really clear on that people can contribute and participate fully in the development without being a member. And we're working very hard to make sure that Brick is open source, that Brick isn't encumbered by any IP, so people can implement it without having to deal with a lot of patent lawyers or anything like that. So we've gone to great lengths to make sure that it's open source and usable by the entire community. So, and I'll turn it over to Gabe.
Yeah, so this is our second to last slide. Just want to point out some of the broad links. Documentation, resources, downloads, reference models are all available on the brickschema.org website. We have a community forum and mailing list that's fairly active. So if you have questions, comments, concerns, things that you want added, you can join that and post and respond to other questions, see what other people are talking about. And then lastly, everything that we're doing is open source, and so the Brick schema definition, the tools that we went over, the translators that we talked over, those are all linked on our GitHub organization when the link is there. And so what I want to emphasize is Brick is open source, it's community driven, which means that it gets better when you get involved, when you bring us the things that the problems that you need to solve, the data that you need to model, the buildings that you need to capture. And so please, leave comments, request changes, or submit your own. We're very open to extending Brick and making it as useful as possible for everybody. And so a big thank you to everyone who's on the talk, and thanks to Jason and Erik for helping me out. There's brickschema.org, and there'll be some links from the talk in that bit.ly link down at the bottom, and we'll make sure that those all the things that we talked about today are easy to find. Thanks very much.
Great, thanks guys. That was a great overview, I think, of what you've been working on, and yes, just a load there to unpack. And of course, I would encourage everybody to go and get involved, basically, right? Wherever that might be, just using the code in your projects, or just testing it out, or actually contributing with with ideas via the different links that we've seen. Yeah, no, actually, I think we got to most people's questions in the chat. If you didn't get anything, or you have some kind of burning question, we've got a couple of minutes, so you can do that now. There is one thing actually that I can see a question that was asked, and guys, I don't know if what the status is of this, but and it ties in with some of the other questions, I guess, right, around like creating, in quotes, the data, the building data standard. But this ASHRAE 223P initiative, is that something that is still running? Has there been any progress with that?
Yeah, so I can speak a little bit about that. So I am on the semantic interoperability working group in ASHRAE that's working on the 223P proposed standard, and it is still an active effort. It is still underway, and there is a group that meets every couple weeks on Tuesday mornings. So if you go onto the BACnet website and you look for the semantic interoperability working group, you can find information about how to get involved or pick up the news. Essentially, what's going on there is what 223 is going to produce is a knowledge graph representation of the building subsystems and equipment and points and all the rest of that, but at a much sort of finer detail than what Brick is currently capturing, and that's a good thing. But it also reflects where the data is going to be coming from. So through ASHRAE, 223P is the kind of standard that we imagine would be adopted by equipment and device and controller manufacturers, so that when you buy a VAV box or you buy an FCU or a lighting fixture, and that connects to your BACnet network or it connects to your building network, it has some RDF metadata that describes how it's put together, where are the sensors, where are the ducts and pipes and wires and all the rest of that, this sort of really fine detailed information that you can really only get from the manufacturer that has that impression of what's there. And you can then stitch together all that metadata from these different components into this much larger detailed knowledge graph that represents how the entire building is put together. And so what Brick then serves is a sort of data analytics schmear on top of that Brick abstracts a lot of those details and brings those concepts closer to the kinds of terms that you would see in your BMS, or the kinds of terms that you would see in your fault detection rules and so on. So they are compatible. Brick is sort of the higher level representation for data analytics, and 223P would be the detailed representation that makes it possible to enable things like Brick. Brick is fundamentally a sort of a brownfield modeling approach, in that Brick was designed when we were going into buildings and we had no idea what was there, and all we had was the point dump. And so Brick is still useful from that point, because you need to be able to describe these systems without knowing exactly how they're put together internally.
Oh, that's really encouraging. So, I mean, as you said, like if you can take a piece of equipment out of the box and it have some RDF descriptors, then it's going to make it much easier to create models, right?
Yes, that's the hope.
Brilliant.
Yeah, so these are absolutely complementary efforts.
There was one other thing, just sort of last one from me anyway, before we finish off. You mentioned it, or I saw it in the chat anyway. Real estate core. That we've done a webinar with those guys as well. And again, I sort of see that as quite interesting, because it's also looking at modeling whole portfolios of buildings. Have you guys been working with them?
Yes, so we actually do have an alignment with Real Estate Core, which is essentially a formal description of how concepts in Brick are expressed in Real Estate Core and vice versa. So they are approaching this much more from a real estate management point of view. There's some qualitative differences between the models, and that's a much longer conversation. But the long and the short of it is, we are we're friendly, we're working with each other, and I think multiple representations of these to try to figure out what's the best way of describing these buildings in different perspectives. That's really just a good thing.
Yeah, absolutely. And I guess it's up to the individual who's writing the code as well. what they use and how they use it. I'm sorry, I can see there's a couple more questions, but we have kind of come to the end now. And look, I mean, these guys are available. I'm sure if you've got questions, comments, want to get involved, go to brickschema.org or GitHub, right? You can post things up on there. Is that right?
Yes, absolutely.
Great. And just remains, I think, me to say the recording will be available. And we'll also try and make sure we get the slides available for everybody as well. So yeah, please share with your colleagues and spread the word. And of course, the Smart Building series of webinars will continue through the year. So just keep an eye out in your inbox or on our website, memoori.com, for more information about the webinars we'll be holding later in the year. Thanks again, guys. Appreciate everybody for contributing and for listening. Bye for now.